Hi there. This is the second video for Chapter 14, Equilibrium, chemical equilibria, however you want to say it. And in this video, I'm going to talk about equilibrium constant equations. One thing, and we actually covered this in Chapter 13, it was one of the book questions. Brackets in chemistry mean concentration of. So if I have HCl dissolved in water at some concentration, I can put that in brackets, and I'd say 2.5 molar. The way I'd read that is concentration of HCl equals 2.5 molar. Brackets mean concentration of whatever chemical is inside the brackets. I could also have like concentration of sodium ions. So concentration of sodium ions. Brackets mean concentration of whatever chemicals inside. And one thing we're going to talk about here are equilibrium constants, KEQ. K in science and chemistry oftentimes stands for constant, and the EQ stands for equilibrium. And it's simply a number that relates the concentration of reactants to the concentration of products for a reversible reaction. It tells us which reaction is favored. Remember, RXN is the abbreviation for reaction. So to figure out this equilibrium constant, which is just a number, we have an equilibrium constant equation. It's a mathematical expression that we use to calculate a reaction's equilibrium constant. And it's written products over reactants. So if I look at this example here, to have this reaction, 2A3B, aqueous, and so forth, double arrow meaning equilibrium. What I do is I take the stuff on the left here, this stuff, and if you notice, here's the KEQ for this equation. The stuff on the left gets tucked underneath. That's what I think of it. You take the stuff on the left, and it goes on the bottom. And if you notice, on the bottom of our KEQ, we have those two chemicals. Now, a few things changed when it became this KEQ equation. First off is the number in front, the 2 here, is now an exponent in your KEQ. The other thing that happened is a plus sign became a multiplication sign. So basically you take the stuff on the left, tuck it underneath, it goes on the bottom of the fraction, put everything in brackets, meaning concentration of. Any of the big numbers in front, any of the coefficients become exponents, and the plus signs become multiplication signs. Now the only things you include in a KEQ are things that we can have a mixture of, a concentration of. So AQs or Gs, gases. Those are two things that we can have concentrations of. If we have heat, we have a solid, we have a liquid, we ignore them. We assume those are constant and we ignore them for the KEQ, so we don't include them. Let's say up here in this example, chemical C was solid instead of aqueous. This C down here would be left off. It wouldn't be in the equation. So it'd just be the D2 times E3 squared, and then on the bottom would be A3B squared, and that's it. KEQ is a unitless number, which is kind of rare in chemistry. And the value of that KEQ tells us some things. If it's greater than 1, the products are favored, meaning there's going to be more products. If KEQ is less than 1, that means the reactants are favored, which means there's going to be more reactants, relatively, or proportionally, I should say. If KEQ is 1, neither the forward or the reverse reaction are favored. So I want to do some examples. Got about 10 minutes left in this video, and this has to do with some examples from from the last video too. So kind of review Le Chatelier's principle. So here's our given equation here. It's exothermic, heat's on the right. We got a double arrow, meaning equilibrium, meaning it's happy right now, it's balanced. And I'm asking what will happen if we add more O2. So here's my O2. If I add more O2, if you remember back from the other video, or if you have the notes in front of you, if you add something, it'll shift to use it up. Another way of thinking that is if you add something, it'll shift away from that thing. So if I add more O2 right here on the left, it will shift to the right. Now, another way to think of this is kind of using a teeter-totter trick here. If I think of that as my teeter-totter, my chemical equation right there is sitting on a teeter-totter, and the balance, the pivot, is where the double arrow is here. So on the left side of the teeter-totter, I have these two things. On the right side of the teeter-totter, I have the CO2 and the heat. So that previous question was, if I add more O2. Well, if I add more O2 to this equation here, thinking of it sitting on the teeter-totter, if I add more O2, what's going to happen is that's going to make that teeter-totter heavier on this side, and the teeter-totter is going to go down. On this side, teeter-totter is going to go up. Well, to fix that, to get back to the balance point, what we would do if we were on that teeter-totter, we would shift our weight to the right. And that would get us back to the balance point. The teeter-totter trick, that might click for you, it might make sense. It might not, just remembering the rules and working through it that way. You know, if you add something, it shifts away. If you remove something, it shifts towards it. Whatever kind of works for you. So this next one, remove CO2. So I'm going to remove CO2. Well, if I remove something, I want to make more of it. And the forward reaction takes carbon and oxygen and makes CO2. So it would make what we've removed. So it wants to replace what we took away. Another way to think of it is if you take something away, it shifts towards it. So basically my answer for number 2 is just an arrow pointing to the right. That's all you have to do for the answers. It's going to shift right, it's going to shift to the reactants, or just draw an arrow to the right. I'm sorry, shift to the products, or just an arrow to the right, away from the reactants. If I increase temperature, again, if I add something, it wants to shift away from it. So if I increase temperature on this reaction, this equilibrium, it will shift to the left. And literally my answer for number 3 is just an arrow pointing to the left. If you add something, it shifts away from it. Temperature decrease, obviously, just going to do the opposite. Going to shift the other way. Let's see here. Let me shrink this down a little bit so we can get some more notes on here. There we go. Pressure is increased. If I increase pressure, if you remember the rule, increased pressure goes to the side of less moles of gas. Well, here I got a solid, I ignore it. Here I got heat, I ignore it. The only thing I'm worried about is gas. Here I have 2 moles, that's what that 2 out front here is, 2 moles of O2 gas. And on this side I have 2 moles of CO2 gas. Well, if you remember, we said if you have the same number of moles on each side, pressure has no impact, no change. So whether you increase pressure or decrease pressure, nothing will happen in this reaction. Now in this reaction, again, pressure increase is going to shift to the side of less moles of gas. Here I have 1 mole of gas plus another 2 moles of gas here, so 3 moles of gas on the left, On the right, I got 1 mole of gas here, but this is a liquid, so I ignore it. This is heat, so I ignore it. So increased pressure, less moles of gas, this would shift to the right. It would shift towards the products. Couple more examples here. I might pause the video here and write out the KEQs for these two things. If you remember, I take the stuff on the left, tuck it under the right, don't include heat, don't include liquids, don't include solids, just gases and aqueous. So I'm going to pause the video and then I'll write down the answers for 8 and 9. If you want to pause the video, try writing the KEQs for number 8 and 9 and then check your answers. 1 second. So they're the answers for 8 and 9. Here I wrote KEQ equals the fraction. Here I forgot to put the KEQ. It's not a big deal. It's the fraction that we're worried about. I ignored the liquid here. I ignored heat here, and I ignored heat here. If there were any solids, I would have ignored those two. I only include gases and aqueous states. And coefficients, like for HBr here, became a exponent. Plus signs, like up here, became multiplication signs. So that's what you should have gotten there. Now, what we can do is I will give you these numbers. So this is information that would be given to you. And for number 9 here, all I'm going to do is I'm going to take these numbers. So for H2, I'm going to take 0.5 molar and plug it in right here for H2. 0.5 molar, plug it in for Br2, and 3.54 molar, I'm going to plug in right here. So I would give you these numbers, and after you have written the KEQ equation for it, you can plug those numbers in and then get your answer. I'm going to pause the video if you want to give that a try. Pause the video, and then you can check your answer in 1 second. Okay, so again, question number 10 is using the same equation as 9. So I have my KEQ, same as from question 9. Stuff on the left goes in the bottom. Brackets, coefficients become exponents, all that stuff. So then once I have it set up and I have all these numbers given to me here, the H2, the Br2, and the HBr, I just plug those numbers into my expression as I wrote it. And remember that the bottom here, HBr, is squared, so I do 3.54 squared on the bottom there. I do that math, and I get 0.01994, and it keeps going. For sig figs, I got 1 sig fig here, so I'm just going to do 1 sig fig, so 0.02. And that is a 2, not a z. And no units, because this is a unitless number. Now the question is, the last question is here, are products favored or are the reactants favored? And the way I think of this is 0.02 is, oops, start over here. 0.02 is less than 1. I think of that as an arrow, the less than sign. So it points to the left. So that would mean that the stuff on the left of a reaction, those are the reactants. So the reactants are favored. So to answer this question, products are not favored basically because our answer is less than 1. If it's less than 1, reactants are favored. If it's greater than 1, products are favored. So that's it. If you have any questions, stop in and do the practice quizzes. If you don't understand something on the practice quiz, again, stop in, send an email or something like that. See you later.